Hello, this is Brian Leonard calling, talking. My voice sounds kind of just real raspy. I'm getting over a pretty bad cold. I've just been out of it for the past few days there, so I'll give this a shot, and hopefully you guys will be able to hear me okay, and we'll just give it a shot. Just want to talk about something that's called adenosine triphosphate. Adenosine triphosphate is energy that all living systems use. So it's abbreviated with adenosine triphosphate. So that's actually what we call chemical energy. Again, what we call chemical energy. And again, this is the molecule that living systems use in order to make and produce energy. Energy to live, energy to function, energy to do things. So adenosine triphosphate, ATP stands for short, is a primary energy carrier in all living organisms on Earth. Think of coal, C-O-A-L, coal. Okay, that's a piece of coal right there, right? Well, what happens is that when you burn coal, when you break coal down, it releases energy. Okay, it releases actually heat and energy. Similar thing with ATP. Okay, so energy is stored in food molecules like glucose. So when you actually take glucose, break it down to make ATP, and then break that ATP molecule down and releases energy and heat just like we do with coal. All right, so you have a particular different food source, okay, be it glucose. Again, these are the things we eat: fatty acid, amino acids. Goes into what's called the mitochondria, MIT, mitochondria. All right, it's broken down into ATP. Again, this is the chemical energy that living systems use. So here's the adenosine triphosphate molecule. All right, so this is the adenine component, ribose component, and triphosphate. So three phosphate molecules. Again, think of this like as coal. We have to break this down in order to release energy into the cells for our cells to be able to function, and for our cells to have energy, our tissues, our organs, and us as an organ system have energy. So again, triphosphate, three phosphate molecules, all right? So again, we want to break these bonds, and it's going to release energy with this ATP molecule. So when we break that last bond, okay, so you got ADP, diphosphate, ADP plus P, energy is released for the cells to use to do work. Again, for running, for breathing, for anything that you can think of there in terms of making things in the cell, be it bacteria cells, be it plant cells, all types of animal cells, mushrooms, fungus, what have you. All organisms need ATP. So again, breaking ATP down, cutting off that last phosphate group, releasing energy to do things. Again, like I said, that last phosphate group is broken, energy is released. Now what happens is that when that last phosphate, that bond is broken, energy is released, but then you have to have the input of energy in order to put that bond back again. So it's a cycle. All right, it's basically like a cycle. It's broken down, added, broken down, added. That's why it's important to eat and to gain resources from outside sources as living organisms. Okay, so again, ATP, high level of energy. If it's broken down to ADP, like this battery, a lower level of energy. So again, the cycle, ATP broken down to ADP plus P, but then we always have to keep on eating to get more energy to put that phosphate, that lone phosphate, back into the system to go from ADP, adenosine diphosphate, di meaning two, adenosine diphosphate to make adenosine triphosphate. Thank you.